A recent study found that the heights of Dutch women can be modeled by a normal distribution with mean 170.7 centimeters and standard deviation 6.3 centimeters. A Dutch woman is chosen at random. Calculate the probability that her height is less than 160. Take X as the variable, the height of Dutch women, follows a normal distribution, mean 170.7, standard deviation 6.3. Normally, when we write symbolically this variable, here we write the variance. This value is the variance. But when using the calculator, we use the standard deviation, which is 6.3 in this case. Then, to calculate the probability that is less than 160, what we're trying to do to find the area under a curve with a mean of 170.7, and then we want the probability that it's less than 160. We want the area of this region. We want the probability that X is less than 160. Less than or equal to, doesn't matter here in the normal distribution, since it's a continuous variable. So let's take the calculators to find this. In Texas, we can go to distribution, and then we go to normal cumulative, and then we leave this number as being the lower bound. This is an extremely large negative number. The upper value is 160. The mean, 170.7, and the standard deviation, 6.3. That's the probability, 0.0447, 0.0447. Let's do the same in Casio calculator. In Casio calculator, we go to menu distribution, then we go to normal, select the right tail. The X value in this case is 160, standard deviation 6.3, and the mean is 170.7. Execute, that's the probability. And now using Nspire, with Nspire, we go to menu, then probability, distributions, we go to normal cumulative, normal CDF. Leave this value as the lower bound, upper value 160, mean 170.7, and then standard deviation is 6.3. And then it gives exactly the same value. Part 2 of letter A. We want to find the probability that her height is between 160 and 170. So in this case, we want the probability of the height being between two values. Here, the mean 170.7, 170.7, and then we want this to be between 160 and 170. So it's 160 and 170 here, close to 170.7. We want to find the probability by calculating this area. So we go to the calculator to go to distribution. We go to distribution and then normal cumulative, lower 160, upper 170, mean 170.7, standard deviation 6.3, and then we paste it 0.411. So probability that X lies between 170 and 100, that X lies between 160, 170, 0.411, 04 to three significant figures, 0.411. If we go to Casio calculator, then we go to distribution, and then we go to normal, and then we select the probability of being between 160 and 170 with the same values for mean standard deviation, execute. In Casio calculator, we sometimes may not be sure about this result, 0.411. We're not sure about the next figure that comes after 1. Then we can go to option and then F1, and then we see all the figures. So the same value, and in the Nspire calculator, we would go to menu, probability, distributions, normal cumulative, and then we would put 160, 170, a mean 170.7, and standard deviation 6.3. And then we would get same result. Let's go now to part B. 27% of Dutch women have a height of more than 8 meters. Calculate the value of age. This is exactly the opposite what we have done before. And then for this reason, we're using inverse normal. We have the normal distribution curve with a mean of 170.7. 27 have a height of more. So let's just estimate that this area here is 0.27. So we want to know what is this value, h, for which the area is 0.27. Going to Texas calculator TI-84, we go to distribution, and then we use inverse normal. The area 0.27 with a mean of 170.7, standard deviation 6.3. Tail right, because the area is to the right of the value. And then we paste this value is 174.56, 174. So the probability that x is greater than h, being 0.27, means that h is 174.56, which rounds to 175 meters. The same could be done in Casio. We can come back here, change the tail to the tail greater than, and then since we don't know the value, we leave any value and just execute, and then we change this accordingly in the diagram. We come here and we write 0.27. And then this is going to give 174. That's the answer we're looking for, 174.56. In Nspire, very similar to TI-84, we go to menu, probability, distributions, and then we select inverse normal. Area is 0.27. But here, the calculator expects the area to the left of the value. So in this case, we cannot put 0.27. We have to put 1 minus 0.27. And then the mean, 170.7. Standard deviation, 6.3. So here, we don't have the idea of tail. So the settings for this calculator is that it's always the area to the left. So we press OK, and then we get 174.56. Janneke selects a random sample of 200 Dutch women from Amsterdam and measures their heights. She wants to determine whether this sample could have been chosen from a normally distributed population with a mean of 170.7 and standard deviation 6.3. She performs a chi-square goodness of fit test at the 5% significance level. She begins by creating the following frequency table. So the table here shows observed and expected frequencies for each class. Calculate correct for significant figures the value of A and B. A is the expected frequency for this class from heights between 160 and 170. We have found this probability this probability is 0.411 to 3 significant figures. So all we have to do to find this expected frequency is to multiply this probability 0.411 by 200, because 200 is the sample size. It's a sample of size 200. The most accurate way to do this is not doing this multiplication 0.411, is getting the calculator and then getting the number with lots of figures, full calculator display, and then times by 200. Then we get an answer that we're going to round to 4 significant figures, 82.21. So this is going to be 82.21. And then for part 2, to find B, we need to find first the probability of being between 170 and 180. We don't have this value here, so we need to do this to calculate this probability. We can get, for example, normal cumulative from here and just change here from 170 to 180, or just go to distribution and do all the way. Here we get this probability 0.474, 0.474, and then we multiply by 200, then we just do times 200, and then we're going to get 94.857, 94.86, 94.86. The same would have to be done in the other calculators in Casio. We would have to go back to the normal screen to do the calculation. And then in this case, in Casio, when we need the same value that we found here, 0.411, but with more figures, would have to come back and write down the value. So here we go to the tail between two values, 106, 170, execute, and then we would just write down this number to see this value with more figures. Then we have to go to option and then F1. So we press the key option and then F1, and then we see more figures. This is needed in this question. So you would have to write this down and in the normal screen, multiply this by 200. And then do the same for the other class between 170 and 180. Okay, so to do this, get here 170, and then here 180, and then we'll get this value. Here it shows more figures, but again, if you need to see more figures, press option and then F1. So you would have to write this down, multiply by 200. The same thing in Nspire, okay? So you would need to get this number, go here, and just time by 200, and do the same for if we want the next, and we need the other class, then we would go again to menu, probability, distributions, and then go to normal cumulative to get from 170, 180, mean 170.7, 6.3. It would get the value and then times by 200, and then we get 94.86. Okay, coming back to this part, the hypothesis for Janneke's tests are the heights are drawn from a normally distributed population with mean 170.7 centimeters, standard deviation 6.3. The heights are not drawn from a normal distribution. Write down the degrees of freedom for this test. For statistical tests, for a chi-squared goods of fit test, the number of degrees of freedom is n-1, where n is the number of categories. In this case, we have 4 classes, 4 categories. It's 4 minus 1. We are not estimating mean and standard deviation from a sample. This value was given for us in the question, so we just take 1. The critical value for this test is 7.815. Perform the chi-squared goods of fit test, state your conclusion, justifying your reasoning. To find to perform the chi-squared, goods of fit test, we need to go to the calculators to find either the p-value or the chi-squared statistics. We get the calculator, and then we go to lists. We insert the values from the table of observed and expected frequencies, observed frequencies in list 1, expected frequencies in list 2. And then after that, we go to statistics, then tests, and then we scroll down until chi-squared goods of fit test. And then we have to inform the degrees of freedom, which is 3, and then calculate. We find the chi-squared statistic to be 1.797, so 1.80. So let's write this down, 1.80. The p-value, 0.616. We can use either this, or we can use either the p-value or the chi-squared statistics. The decision rules are different from each case. So we reject H0 if the p-value is smaller than the significance level. The significance level is 5%. So we compare p-value to the significance level. So in this case, we would reject if 0.616 were smaller than 0.005, but it's not. It's greater than 0.005. So we fail to reject or do not reject H0. So H0 is true. The data comes from a normal distribution. Using the p-value, we compare this to the critical value. In this case, we would reject if the chi-squared statistics 1.80 were greater than the critical value, but it's not. 1.80 is smaller than 7.815. So for the conclusion is the same. We do not reject H0, fail to reject H0, or even not enough evidence to reject H0. So we can use one way or another. They give the critical value, but it's not needed if you want to use the p-value. Use one way or the other, okay? In Casio, we go to statistics, and then we insert observed in list 1, expected frequencies, list 2. Then we go to test, select chi by pressing F3, and select Goff goods of fit F1. We have to tell the calculator the degrees of freedom, which is 3. Then here, observed list 1, expected list 2. That's the standard setting. And then we go to execute. We get exactly the same values, okay? In Nspire, we have to go to the initial screen, select lists, and then we have to tell here the values observed and expected. I've already inserted this to make it faster. And then I select menu, statistics, statistical tests, chi-squared goods of fit test. So the observed list is list A. So we have to write A and these square brackets. Expected in B, degrees of freedom 3. And this is the list where the results are going to be displayed. I'm going to select C. So when we do this, here we have the values, chi-squared statistics, and the p-value. Okay, so Gundiga claims that on average, Latvian women are taller than Dutch women. Random samples of 10 Latvian women, 10 Dutch women are chosen and their heights are measured. Gundiga performs a t-test at a 5% significance level. It's assumed that the populations are normally distributed and have equal variances. Write down new and alternative hypotheses for this test. So we're gonna say in this case that the new hypothesis is that the mean of Latvian women is equal to the population mean of Dutch women. So mu L will represent the population mean of Latvian women, mu D, the population mean of Dutch women. The null hypothesis for a test, for a two-sample t-test, is always that the two means are the same. The alternative, in this case, is that Latvian women are taller than Dutch women. So this sentence is the sentence that's telling us the alternative hypothesis. So that's what we are testing, in fact. We're testing if the mean population of Latvian women is greater than the mean population of Dutch women. Then we have to insert these values in the calculators. Okay. Once this is inserted in our calculators, then we can perform the test, go into statistics, and then go into tests, and then selecting a two-sample t-test. Then we're gonna use data because our information are stored in the lists L1, L2. The alternative hypothesis is that the first mean is greater than the second. It's very important that pooled need always to be selected as yes. It's mandatory that is yes in the IB exams, okay? So we select calculate, and then we are gonna get a p-value 0.673. So the p-value is 0.673, which is greater than 0.05, the significance level. So not enough evidence to reject 80. So we say that the mean of Latvian women is equal to the mean of Dutch women. In the other calculators, we follow the same. If we go to Nspire, I've already inserted the values here. Then we would go to menu, and then statistics, statistical tests, and then go to two-sample t-test. Select data. Then list one is gonna be in A, in column A. Then here B. Alternative hypothesis is that the first mean is greater than the second. Hold yes. And then we just select OK. So here it's this p-value 0.673. Now we go to tests, then t-tests, and two-sample t-tests. The alternative hypothesis has been selected. In this case, we are using lists, not var. The first mean is greater than the second, and then put on, in this case, always on, corresponds to yes on the other calculators, and then execute, and then again, p-value 0.673.